Good morning, children. Hope you are safe and doing good. In previous class, we learnt about the air. Air is the mixture of gases. We learnt about the physical and chemical properties of oxygen, nitrogen and carbon dioxide. Today, we are going to learn about sound. In our daily life, we are hearing a variety of sound. When raindrops fall on the water as well as the ground, we can hear the different sound. Thundering of clouds, mewing of cats, noise of the vehicles. We can hear the varieties of sound in our daily life. So, each sound has particular characteristics. Yes? Yes. So, we communicate each other through sound. Some sound like music is pleasing our ears, but some noises we doesn't like, isn't it? So, today we are going to learn how is sound produced. Production of sound. Sound is produced when an object set to vibrate. Here you can see that the object is vibrating. Sound is produced when an object set to vibrate. Vibration means a kind of rapid to and fro motion of a particle. Here you can see this picture. So what is vibration? Vibration means to and fro motion of the particle. Yes. So these to and fro motion causes the particles around the substance to set to vibrate. Okay. This to and fro motion causes the substances around it to vibrate. So how is sound produced? When an object set to vibrate, sound is produced. Let us see an activity. You can take an empty box and a rubber band. You can take an empty box and stretch the rubber band around it. Okay. So on plugging the rubber band, you can hear the humming sound. So as long as the rubber band is vibrating, you can hear the humming sound. This activity clearly shows that when the object vibrates, sound is produced. When an object is vibrating, the sound is produced. Okay, here you are seeing the sound waves. Its sound waves travels through one place to another. Okay, you can see the examples of the sound is produced by vibrating particles. For example, it's a stringed instrument such as guitar. You can see the guitar and sitar. The sitar, you can see this is the stringed instrument. It gives the strings vibrating as long as you can hear the sound. When the strings stop to vibrate, you cannot hear the sound. Okay. How is sound spreads to the surroundings? The sound won't spread to the surroundings. We need a medium. Yes. The substance through which a sound is transmitted through one place to another. That is called a medium. So, the sound won't spread to the surroundings. We need a medium. Okay. The sounds move through a medium as from the point of the generation to the listener. Here you are saying that the door gives the sound and then the other person, he is standing at a distance, he is hearing the sound. So, no? It's through the medium. He is listener. He is hearing the sound through the medium. Okay. The propagation of sound. We all know that, no? The sound is the form of energy. Okay. So, you are standing near one place and your friend is standing at a distance. Now you are calling your friend. He is hearing your sound. How does he hear your sound? Yes, you know that the sound travels one place to another through a medium. Yes, it needs a medium to travel. So, you're calling your friends that is the sound travels from here to there through air. Here air is your medium. Okay. Sound cannot travel in vacuum, and it needs a medium like air. So sound can travel through air. So it cannot travel in vacuum. If there is no medium, the sound cannot travel through one place to another. Okay. Here the sound can travel through only medium, but it cannot travel through the vacuum. We know that the sound travels through air. That the sound travels in water and solid also. So the sound can travel through water, solids and air. That is solids, liquid and gases. Yes? Okay. The speed of the sound is more in solid than in liquid. The speed of the sound travels in solid is more than the liquids. It is very less in gases. The speed of the sound travel in gases is very less. Okay, the speed of the sound is the distance traveled by sound in 1 second. What is the speed? How to find out the speed of the sound? It's the distance traveled by the sound in 1 second. The speed of the sound is the distance traveled by the sound in 1 second. Okay. Now, we said no, the speed of the sound is the distance traveled by sound in 1 second. So, it is denoted by the letter V. So, how to find out the speed of the sound? That's the letter denoted by V, and then it is represented by the expression. How to find out the speed of the sound? V equal to N lambda. We can use this formula, that is V equal to N lambda, and to find out the speed of the sound, where N is equal to frequency and lambda equal to wavelength. This is lambda. V equal to speed of the sound, and then N equal to frequency and lambda equal to wavelength. Then we can do it one problem. Okay. How to find out the speed of the sound? Okay, a sound has a frequency of 50 Hz and a wavelength of 10 meter. What is the speed of the sound? So, what is the formula? So, V equal to N lambda. Yes, V equal to N lambda. Here they can given the frequency N 50 Hz and the lambda wavelength 10 meter. Okay. So how to solve this problem? V equal to N lambda. We can substitute the value of N and lambda, and then you will get the answer. That is 500 ms power minus 1. So unit is ms power minus 1. Meter per second. Meter per second. Now you know how to calculate the speed of the sound? Yes, using this formula. What is the formula? V equal to N lambda. So what is N? N is a frequency and lambda is a wavelength. The speed of the sound depends on the properties of the medium through, it's like a temperature, pressure and humidity. The speed of the sound depends on the medium. Okay, it's a temperature. It affects the speed of the sound. The temperature affects, pressure affects the Speed of the sound. Okay. In any medium, it is a solid or liquid or gases, as the temperature increases, the speed of the sound also increases. I said in any medium, it is a liquid or gas or a solid. In any medium, as the temperature increases, the speed of the sound also increases. For example, you can see here, the speed of the sound in air is 331 meter per second at 0 degrees Celsius. So what is the speed of the sound in air at 0 degrees Celsius? 331 meter per second. Meter per second means meter per second. You can write ms power minus 1 or m per s. Okay. Okay. But at 22 degrees Celsius, the speed of the sound in the air is 344 meter per second. 344 meter per second. Here, you know that as the temperature increases, the speed of the sound also increases. Here you can see that at 0 degree, 331. But at 22 degrees Celsius, it has increased 344 meter per. The number is increased. So we know that in any medium, as the temperature increases, the speed of the sound also increases. We saw that sound travels in different speed in different medium. Now let us see that how the sound travels in a medium. So when a body vibrates, the particles of the medium in contact with the vibrating body is first displaced from its equilibrium position. Then what will happen? It exerts a force on the adjacent particles. And then the process is continuing. What is the process? When the body vibrates, its contact with the medium. This process continues in the medium till the sound reaches the ear of the other person. Okay. So let us see that in order we want to understand that, let us consider the vibrating tuning fork. Okay. So when you are taking this vibrating tuning fork, moves forward, it pushes and compresses the air in front of it. So when it's moved forward, it compresses and pushes the air in front of it, creating a region of high pressure. Here creating the region of high pressure, this region is called compression. Okay. Then it's moved backward, it creates a region of low pressure called rarefaction. Sound as the form of energy. We know that the sound is the form of energy. When the sound is transferred through any medium, that is air or any other medium, in the form of mechanical waves. The sounds travels through the medium in the form of mechanical waves. So now we want to see the characteristics of wave motion. Okay. So only the energy is transferred, not the particles. The particle is vibrating, no? That particle is not transferred. Only the energy is transferred. Only the energy is transferred, not the particles. And then velocity of the wave motion is different from the velocity of the vibrating particle. Okay. The distance traveled, the speed of the wave motion is different from the speed of the vibrating particle. Okay. And then for the propagation of the mechanical wave, the medium must possess these following properties. The first property is inertia. It remains unchanged. And then the elasticity. When it's stretched out, it will come in the same position, isn't it? The proper position. And then the uniform density and then minimum friction among the particles. Mechanical wave. There are two types of mechanical wave. They are, the first one is transverse wave. The second one is longitudinal wave. The first one is transverse wave and the next one is longitudinal waves. So we can see the transverse wave. The transverse wave, the particles of the medium vibrate in a direction. So when the particles of the waves vibrate in one direction, that is a perpendicular direction of the propagation of the wave. You see that? It is the perpendicular direction of the wave. Okay. So it also produced only solids and liquid. The transverse waves produced only solids and liquids. Okay. And then, for example, it's waves in strings and light waves. Okay. Here you can see the transverse wave. How it's moving. It's in the perpendicular direction. Okay. Then the next wave is a longitudinal wave. So this longitudinal wave, the particles of the medium vibrate in a direction which is parallel to the direction of the propagation of the wave. So waves in springs, sound waves in a medium. Okay. So these longitudinal waves produced in solids, liquids and also in gases. We saw that in the transverse wave only solids and liquids. The waves produced only in solids and liquid. But in the longitudinal waves, it produced in solids, liquid and gases. Okay, here you can see that the parallel vibration, longitudinal waves, how it is moving. Yes, it's nice to see. Okay, this is transverse wave. It's moving in the perpendicular direction. This is the longitudinal waves. It's moving in the parallel direction. So do you all understand, children? Yes? Yes.
Let's have a recap. Today we learned the topic sound. In that we learned the production of sound, propagation of sound, wave motion and then mechanical waves. We learned there are two types of mechanical waves, transverse wave, longitudinal waves. Transverse wave produced in solids and liquids, but longitudinal waves produced solids, liquids and gases. Do you all understand, children? Yes. Thank you, children.